So now let's look at a small sample hypothesis test. In example 10, the price of a popular tennis racket at a national chain store is $179. Portia bought 5 of the same racket at an online auction site for the following prices, and we have 5 pieces of data. Assuming that the auction prices of rackets are normally distributed, and we need that normally distributed to do the test, determine whether there is sufficient evidence in the sample at the 5% level of significance to conclude that the average price of the racket is less than $179 if purchased at an online auction. All right, so let's notice that less than is giving us our alternate, whereas the very first statement is giving us our null hypothesis, that the price of this tennis racket is $179. All right, so let's first set those up. So we have our null hypothesis is that our mean mu is 179, and our alternate is online. We think maybe we can get that for less than 179. All right, and then we had our significance was 5%, I think. Let me go back. Yes, it was. So alpha is 0.05. Now notice, since our alternate is a less than, when we were using the z functions or the normal distribution, standard normal distribution functions in Excel, it always gave us the area to the left, and that's true also as we get ready to use the t distribution functions. And since this is a small sample, we're going to have to use the t distribution functions. Before, let's go ahead and look that up first. But we're going to we're going to do t, oops, don't forget my equal sign. Our command is equal t.inv, and we're going to put in our probability of 0.05. And in this case, if we look back, there were 5 pieces of data here. Our degrees of freedom is always 1 less than that. So our degrees of freedom that we're going to put into Excel is going to be 4, and then we'll hit enter. So we're looking at negative 2.132. All right, so the t value, our critical value, is negative 2.132. All right, now before we can actually do our test statistic, we need to find the mean and the standard deviation, because all we were given was the data. So let's recall how to do that in Excel, because it's been a while since we've had to do it. First, let's take our data, which was, and I'll put them into one of the columns, 155, 179, 175. You'll be able to cut and paste those in your homework, but here they're written horizontally, which makes it a little bit hard. And then 175 and 161. All right, so recall, let's start with our mean. To get the mean, we said equal average, and then we needed to tell it what the first position was. In this case, it's in column D, and this is actually position 1. Let me move this over so you can actually see that. All right, so this is D1. And then my last one is at D5. And notice, of course, it highlights it. And so there's our mean, it's 169. Now let's get our standard deviation. So we want equal standdev.s, and again, we're going to tell it D1, oops, to D5. And there's our standard deviation. Now that we've got those 2 things, we can go ahead and do our test statistic. Okay, so our test statistic for a small sample, the setup looks exactly the same, except it's a t instead of a z. But we're still going to have our sample mean, which in this instance was 169. So we'll have 169 minus the mean that we have for our population, 179, divided by, notice this is still the same calculation, our sample standard deviation, which was 10.3923. Divided by the square root of the sample size, which in this case there were 5 in our sample. So now we want to do those two calculations in our calculator. The top is going to give us -10, and for some reason Word is, there we go. And the bottom is going to give us 4.647578. And then let's divide those two out. That gives -2.152. Oops, 152. All right, now let's remember this is a left-tailed test. So our rejection region is to the left of -2.132. And -2.152 is certainly to the left of -2.132. Not by very much, but it is. So this is in the rejection region, which means we reject the null. All right, so let's state our conclusion. There is sufficient evidence to reject the null hypothesis. And since we're using the very first method we have, we'll state our alpha value. In this instance now, it meant that online you could get this product, what was this product? Tennis racket, for less than 179. So let's just write that. It appears that online you can, oops, and I'm running off the page here. Let me move this over. Move my window a little bit. You can purchase the tennis racket for less than $179. All right, now, we're actually finished with this example, but let's suppose that we had been asked to do it by the p-value approach instead. What would be different? Well, these first 3 steps would be the same. We would not have found the critical value. We would have gone straight to our test statistic. And then once we got our test statistic, we would find the p-value for the test statistic. So let's use Excel to find that p-value. So it's -2.152. If we go here, it's going to be equal t.dist -2.152. Our degrees of freedom, remember, we're 1 less than our sample size, so we put 4, and then we have to put the word true. And it gives us a p-value of 0.04, and let's round off to 4 decimal places, so 0.0489. All right, so going back, it would have gone right here, p-value equals 0.0489. And remember, when the p-value is less than alpha, which it is in this case, we reject the null hypothesis. So notice the result would have been the same whether we had used the first approach where we're just using alpha and our critical values, or our p-value approach where we don't find our critical value, but we find our p-value and compare it to alpha. The result is the same.